Study Section 3 Factor-Specific Model. Introduction. In the earlier chapters, it was demonstrated that international trade can be mutually beneficial to the nations engaged in it. In the Ricardian case, trade leads to international specialization, with each country shifting its labor force from industries in which labor is relatively inefficient to industries in which labor is relatively more efficient. One important lesson from the model is that since labor is the only mobile factor, trade does not affect distribution of income and hence every individual gains from trade. However, in the real world, trade affects income distribution, and at times such distribution appears to be uneven. Two reasons can be advanced for this. First, in practice, factor cannot move costlessly or immediately from one industry to another or from one country to another. Second, firms demand for factors in different ways. While some industries demand for more land and capital, some demand for more capital or natural resources. As countries shift production from one sector to another, demand for factors will be high in one and low in the other, so that benefits are distributed unevenly. For these reasons, a realistic analysis of trade must go beyond the Ricardian model to models in which trade can affect income distribution. In this chapter, we shall incorporate income distribution into the picture of trade analysis. The specific factor model. The specific factor model was developed by Paul Samuelson and Ronald Jones in 1971. This model bears some similarities with the Ricardian model. For instance, it assumes an economy that produces two goods and labor is allocated between the sectors that produce the two goods. However, the model departs from the Ricardian world by extending factors of production beyond one. Not only that, the model assumed that a factor is specific to the production of a particular good. Also, labor is homogeneous and mobile. That is, one of other factors, say capital, can only be used in the production of a particular good, while labor can move across industry. To fix the idea, assuming that Nigeria can produce two goods, oil and agriculture, the country has three factors of production: natural resources R, land F, and labor L. Oil is produced using natural resources and labor but not land, while agriculture is produced using land and labor but not natural resources. Hence, labor is a mobile factor that can be used in either sector, while natural resource and land are both specific that can be used only in the production of one good. The production of oil, therefore, depends on the amount of natural resources and labor used, while the production of agriculture depends on the amount of land used. Thus, the production function of each sector can be specified as follows: where Q0 and QA are output of oil and agriculture respectively, and L0 and LA are amount of labor allocated to oil and agriculture sector respectively. The model also assumes full employment, and therefore total labor in the economy must be exhausted by the two sectors, that is, L0 plus LA is equal to L. Question 3.3. Properties of the production function. Natural resource and land are specific to oil and agriculture respectively, while labor can shift from one sector to another. We assume that the specific factor is in fixed quantity, so that it is the shifting of labor that determines output mix. If labor shifts from oil to agriculture sector, output of agriculture sector will increase. But since there is a fixed length, it means that as labor shifts from oil sector to agriculture, agriculture output increases at a decreasing rate, indicating that the production function exhibits diminishing marginal returns. It can also be the case that labor are moving from agriculture to oil sector, and by the same token, the production function of oil sector also exhibits diminishing marginal returns. Figure 3.1 below shows the slope of marginal product of labor, which measures the additional output generated by adding one or more units of labor to work in agricultural sector. It is possible to also relate marginal product of labor to labor input. We know that given a fixed area of land, increase in labor input in agriculture sector will reduce the marginal product of labor in agriculture sector. Thus, there is an inverse relationship between marginal product of labor and labor input. Let us consider the case of oil sector. Let us assume that labor shifts from agriculture to oil sector. As noted earlier, this will lead to increase in oil output. But as more and more labor moves to work in the fixed natural resource of the oil sector, oil outputs tend to increase at a decreasing rate. Figure 3.2, the production function of oil sector. The production function of the oil sector, which relates output to labor supply, is given in figure 3.2. The same explanation for figure 3.1 applies to figure 3.2 with a slight modification that we are referring to oil sector instead of agriculture sector. The relationship between marginal product of labor in oil. The sector also has the same shape. Take 2. The sector also has the same shape and similar explanation as in agriculture sector in particular. Figure 3.2 is similar to figure 3.1. Also, the same explanation is given for both, only that while figure 3.1 explains the properties of production function in agriculture sector, that of figure 3.2 and 3.3 explain properties of production function in the oil sector. Figure 3.3, the marginal product of labor in oil sector. The next step is to try and derive the production possibilities frontier, PPF. Recall that PPF shows the pattern and what the economy is capable of producing. In an economy where only two goods, oil and agricultural products, are produced, the PPF shows the pattern and amount of oil and agriculture that can be produced given land, natural resources, and labor available. Specifically, the PPF shows the amount of oil to be produced given the amount of agriculture produced. The PPF is derived from Take 2. The PPF is derived from amalgamating the entire 4 graphs above. This is demonstrated in figure 3.4 below. Figure 3.4, the PPF in specific factor model. Quadrant Take 2. Quadrant 1 shows the production function of agriculture, while quadrant 3 shows that of oil. Quadrant 4 shows labor allocation among the two sectors. This line is negatively sloped, indicating that if labor increases in oil sector, it will lead to a decrease of labor in the agriculture sector. Now, take point 2 in the labor allocation line. For example, the marginal productivity of labor in oil sector is at point A and the output produced is at Q02, while the marginal productivity of labor in agriculture is at B and QA2 output was produced. Note that the amount of labor used in agriculture is greater than the amount used in oil, and as shown in quadrant 2, output of agriculture is greater than output of oil. Clearly, the production of oil and agriculture is determined by labor allocation. Clearly, the production of oil and agriculture is determined by labor allocation. Now, when labor is shifted from oil, say from point 2 to point 3, the extra input labor will increase output in agriculture sector by the marginal product of labor in agriculture. MPLA, what this implies is that to increase agricultural output by 1 unit, labor input, take 2, labor input must be increased by 1 over MPLA. However, each labor shifted from oil sector will reduce oil output by the amount of the marginal product of labor in oil, MPL naught. That is, increase in agriculture output by 1 unit will reduce output of oil by MPL naught over MPLA. Consequently, the slope of the PPF becomes price, wages, and labor allocation. In the earlier sector, we showed how output is determined given the allocation of labor. In this section, we shall concentrate on how labor is being determined. That is, we shall determine how much labor will be employed by each sector. In a perfectly competitive market, the demand for labor depends on the price of output and wage rate. The higher the wage rate, the lower the labor demand. The higher the unit price of output, the higher the labor demand. Meanwhile, wage also depends on combined demand for labor in the two sectors. Our knowledge of microeconomics informs us that a profit-maximizing employer will continue to hire labor until the value of an additional output produced is equal to the going market wage. The value of the marginal product is obtained by multiplying marginal product of labor by the output price. Thus, the wage paid in the agriculture sector becomes, since MPLA slopes downwards, MPLAXPA will also slope downwards. Thus, equation 3.4 is the demand curve for labor in agriculture. That is, demand for labor rises with decrease in wages and falls with increase in wages. By the same token, if the wage in oil sector falls, labor demand will rise, while if it rises, labor demand will fall. That is, since labor is mobile, it will seek for the sector that pays higher. As labor shifts to the high-paying sector, other sectors will experience scarce labor, and this will push wages up in the sectors. This in turn will create incentive for labor to move to that sector. This process will continue until a particular wage, which will create no incentive for labor to move from either sector, is reached. Figure 3.5, the allocation of labor. This type of wage established by the forces of demand for and supply of labor is called the market wage or the going wage, or technically the equilibrium wage. This equilibrium wage in the economy can be established by combining figure 3.4 and 3.5. The outcome is presented in figure 3.6 below. Relationship between labor allocation, relative price, and output. The horizontal axis is the total labor supplied L. The left side graph shows the value marginal product of labor in oil sector, which is equivalent to demand for labor in oil sector. The right side graph shows the value marginal product of labor in agriculture sector, which is also the demand for labor in agriculture sector. The intersection of the value marginal product of the sectors, point E in the diagram, gives the equilibrium wage W. Point V on the horizontal axis gives the appropriate labor allocation to each sector. In particular, at W, labor demand by oil sector is OV, while labor demand by agriculture sector is VO. From the graph, we can establish the following relations. Equating W is equal to W, we have divide through by MPLA and then by P0 to get. If we consider the fact that VPLI, I is equal to 0, A in bracket is downward sloping, then they will carry negative sign such that equation 3.8 shows an important relationship between relative prices and output emerging from allocation of labor. Precisely, the equation says that the production point, the slope of the production frontier given by, should be tangential to the slope of relative price, the price of oil. What does this mean? Let us use graphical exposition to get a clear picture of what we are trying to say here. Look at figure 3.7. The PPF line slopes downwards and its shape is determined by figure 3.6, production in the specific factor model. Relative price line is tangential to PPF at point E. This point shows the amount of oil and agriculture to produce. For instance, at that point, Q0 amount of oil will be produced together with QA amount of agriculture. It follows that if P0 and PA changes, the slope will change and respective output will also change. Note that the way output changes depend on whether the changes in prices of oil and agriculture are the same or differs. Let us assume that the price of oil and agriculture each rises by 5% proportionate increase in price. The graph below informs us about how labor allocation, output and prices will look like. Take 2. Figure 3.7 shows that. Figure 3.7. The allocation of labor with proportional increase in output prices. With equal increase in commodity prices, labor allocation remains the same. Output also remains the same, but there is a new equilibrium wage that is higher than the earlier one. Thus, when there is a proportional change in relative price, no real change will occur. Now, consider a disproportionate change in relative price, assuming that oil price rises by 5% while agriculture price rises by 7%. This implies that agriculture price is 2% higher than oil price. Figure 3.8 shows what will happen. Because of higher price in agriculture, labor will shift from oil to agriculture, and this will shift the marginal product of labor in agriculture to the left. Two important facts can be noted from this scenario. First, though equilibrium price rises, it is less than the proportionate increase in relative price. Why? Second, as labor shifts to agriculture sector due to 2% differential in wages, output of agriculture also rises while that of oil sector falls. Why? Relative price and distribution of income. Having examined the PPF and how relative price relates to output through allocation of labor, we turn to how this affects income distribution. In the diagram below, figure 3.8, an increase in agriculture price to the tune of 7% leads to an increase in output less than 7%. Say 4%, this implies that if oil price rises by 5% and agriculture prices rise by 7%, we should expect wage in agriculture to rise by say 4%. What will be the effect of this change on the owners of resources, labor, land, and natural resources? Workers in agriculture find out that their wage rises but less than the increase in the price of agriculture, 7% increase in price and 4% increase in wages. Thus, their real wage has fallen in terms of agriculture, but it has actually risen in terms of oil. Thus, we cannot say a priori whether workers in agriculture are better off or worse off. We need more information about their preferences for the two goods in their consumption basket. If they consume more of oil than agricultural goods, then they are relatively better off. If they consume more of agricultural goods than oil, they are relatively worse off. What of owners of resource? A shift of labor to agriculture reduces oil output and reduces the usage of natural resources. This will reduce payment for usage of natural resources. Thus, in terms of the price of oil, owners of natural resource will be definitely worse off. What about the landowner? Increase in price leads to less increase in wage, and therefore owners of land are definitely better off. In summary, in the specific factor model, owner of a factor that is specific to the production of a particular good gains if there is a disproportionate upward increase in the output price of the good for which the factor is specific, while the other owner will lose. Owners of labor may gain or lose depending on their preferences. International trade and the specific factor model. Let us consider trade between Nigeria and Indonesia. For trade to take place, the two countries must have different relative price of agricultural goods that would prevail in the absence of trade. Price differences may occur for at least two reasons. First, if the countries have different relative demand. That is, the demand for agriculture by Indonesia may be higher, lower than Nigerians. Second, if these countries have different relative supply of agricultural goods. That is, if Nigeria produces more quantities of agriculture than barrels of oil relative to Indonesia. To fit the ideal, we shall assume that consumption differences excess demand are not the basis for trade. That is, relative demand in both countries are the same. In this case, given the relative price PA over P0, each country will consume oil and agricultural products in the same proportion. Consequently, they will have similar relative demand curve. And therefore, trade is not a function of demand condition. We therefore focus on how difference in relative supply causes international trade. Relative supply differentials may occur as a result of differences in technologies, the Ricardian case, or differences in resources. Since we are not in the Ricardian world, one-factor model, we shall assume that differences in relative supply is caused by differences in resource endowment. Now, assuming that the area of land cultivated increases, what effect will this have on the production and labor allocation? This situation is shown in figure 3.9 below. Consider Nigeria having abundant land area relative to Indonesia, whereas Indonesia have abundant natural resources relative to Nigeria. Clearly, Nigeria should produce a high ratio of agriculture to oil at any given price, while Indonesia should produce high ratio of oil. Increase in cultivated land increases labor productivity in agriculture and shifts the marginal product MPLA to the right from MPLAXPA to MPLAXPA. At a given relative price, increase in demand for labor in agriculture shifts equilibrium wage from E I* to E *I*. More labor withdrawn from oil sector to agriculture, and this will raise agricultural output. Increase in agricultural good occurs for two reasons. First, workers have increased in number in agriculture sector and they have more land to work with. Second, output of oil will fall because workers have reduced. Thus, for any given relative price, an increase in the cultivated area of land will increase agricultural output and decrease oil output. In Indonesia, with increase in the discovery of natural resources, demand for labor will increase in the sector and this will increase oil production. Thus, given relative price, increase in natural resource in Indonesia will increase oil output and decrease agricultural product. Consider Nigeria and Indonesia having the same labor force, but Nigeria have larger supply of land while Indonesia has high supply of natural resources. We can graphically demonstrate that the relative price of agriculture will be higher than world relative price of agriculture in Nigeria, while the relative price of oil will be higher than world's in Indonesia. Nigeria's relative supply of agriculture and oil RSN lies above and to the right of Indonesia's RSI. This is so because with large area of land and less natural resource relative to Indonesia, Nigeria produces large quantity of agricultural product and relatively little oil at any relative price. The converse is the case in Indonesia. With the same relative price, what relative demand out the world is each country's demand curve. Thus, when both countries open up to trade, what output lies between the autarkic output. Also, the world relative price lies between the pre-trade prices. Hence, trade has increased agriculture price in Indonesia and lowered it in Nigeria. That is, where TOT is terms of trade, the world relative price. relationship among prices, production and consumption. Consider a situation of no trade. By assumption, what Nigeria produces will be what it consumes. The same applies in Indonesia thus. International trade makes it possible for the mix of agriculture and oil consumed to differ from the mix produced. However, even though there exists consumption and production differences, a country's consumption depends on the income level. That is, the value of production will be. The left-hand side of equation 3.10 gives Nigerians import of oil demand greater than supply, while the right-hand side gives the relative value of Nigerians' export of agriculture. Thus, equation 3.10 tells us that import of oil by Nigeria from Indonesia equals the product of agriculture export and the relative price. One insight from this equation is that the economy in Nigeria cannot import more than what it can export. The equation is usually called the economist budget constraint. We can repeat equation 3.9 and 3.10 for the case of Indonesia. In this case, Indonesia's import demand for agricultural products from Nigeria is the product of relative price and net export of oil, Indonesia's budget constraint. Income distribution and the gains from trade. Thus far, we have established the fact that production possibilities are determined by resources and technology. We have also seen how relative prices dictate choices of production and how a change in relative price affects the real incomes of different factors of production, and finally, how trade changes relative prices. The next line of action is to examine the gainers and losers in trade. To do this, note that without trade, Indonesia will have low relative price of agriculture. After trade, the relative price of agriculture rises in Indonesia. After trade, the relative price of agriculture rises in Indonesia. Thus, owners of natural resources will be better off in Indonesia. The welfare of workers is ambiguous, while owners of land is worse off. In the case of Nigeria, without trade, low price of oil, and after trade, the relative price of oil will rise. Hence, owners of land are better off, while owners of natural resource is worse off. Again, the after-trade welfare effect of labor is ambiguous. What this implies is that trade benefits the factor that is specific to the export sector of each country, but hurts the factor that is specific to the import competing sector with ambiguous effect on mobile factors. It follows that there are losers and gainers in the factor-specific model. But does the gain from trade outweigh the loss? The better way to answer the question is to ask the gainers if they can compensate the losers. Generally, the reason why trade potentially benefits a country is that it expands the economy's choices. This expression of choice means that it is always possible to redistribute income in such a way that everyone gains from trade. Specific factors model allows for a distribution between general purpose factors that can move between sectors and factors that are specific to particular uses. In this model, differences in resources can cause countries to have different relative supply curves, and thus causes international trade. The factor that is specific to export production gain from trade, while factors that is specific to import competing sector is worse off. Mobile factors, in this case labor, that tend to work either in any of the sectors may either gain or lose, depending on preferences for each product. This is the end of study section 3. Thanks for listening.